Hello and welcome to Diplomatic Derivatives. In today's video, we're going to talk about one of the questions from the past papers in CSS, that is, write all the cyclic subgroups of Z18. Now, in most of the past papers, you might have seen such kind of questions where you have to write the cyclic subgroups of a given group. So this is a very important question, and for understanding this question, first of all, you need to understand the concept behind it, which is from one of the theorem that we have done in one of the previous videos. So for that, you can check the link in the description box below. Before moving on to this example, kindly first go and check out the video to make your concepts clear and then move on to this question. So let's see what the theorem itself is. Just a slight overview and then move on to the question. The theorem itself is, let G be a cyclic group of order n. So it's a group G and the order is n. There exists one and only one subgroup of order D if and only if D divides n. So whatever the group is given to us, there is going to be a subgroup for it, right? And more than one subgroups, right? Those subgroups are going to be unique. Okay, make sure we're talking about the cyclic groups. Okay, we are talking about cyclic groups. So for a cyclic group, whatever a cyclic group is, it will have certain subgroups, and those subgroups exist only for the divisors of the order of the main group. Okay, so therefore what this basically means is that the subgroups are unique. And for example, if the order is n, which is, let's suppose it's 6, right? So what are all the numbers that divide n? The subgroups will have those orders. Okay, the subgroups that are generated by that cyclic group will have only the orders of the divisors of n. Okay, so make sure you check out the previous video for this. Now, first of all, the question given to us is about Z18. What is Z18? It's a group of integers modulo 18 under addition. Again, we have done the modulo group in detail, so make sure you check out those videos as well. So basically, Z18 is a group which is 0 till 17, total 18 number of elements, right? Its operation is addition mod 18. It's a cyclic group of order 18, and its generator is 1 because 1 generates Z18. What does this mean? That with the help of 1, we get the rest of the elements. Therefore, 1 is a generator. 1 plus 1 gives us 2, 1 plus 1 plus 1 gives us 3, and so on till 17. Then 1 plus 1 plus 1 18 times will give us 18 mod 18, which is 0. Okay, so we get 0 as well. So 1 is basically generating the entire group, right? Therefore, this is a generator. 1 is the generator. So what are the two main things you have to remember? The order of the group and what generates the group. So if you know what generates the group, you will be able to make a group, right? For example, if you have a subgroup and you want to know what is you want to make a subgroup, right? Which is what we're going to do in this question. You need to know the generator of that subgroup. Once you know what generates that subgroup, you will be able to make the entire subgroup, right? So the main thing to understand is we need the generator to make the cyclic subgroups, right? First step, divisors of 18. So you are given a group. That group over here is Z18, right? You have to make the cyclic subgroups for that group. So what do? First of all, you take the order. What is the order? N, which is 18, right? Then you write down its divisors. So the rule here is that the subgroups of a cyclic group exist only for the divisors of the order. Subgroups are only for the divisors of the order of the cyclic group, right? That is why we need the divisors. Again, this concept comes from that theorem that I already talked about. Okay, so we write the divisors of the order of the cyclic subgroup, cyclic group, which is 18, and the orders are 1, 2, 3, 6, 9, and 18. So now we have the divisors. Okay, so basically what does this mean? That for each of this divisor, we have exactly one subgroup. Okay, so this is what we want. We want subgroups, right? So how many subgroups do we need? We need all the subgroups, right? So how many are they? They are the divisors of the order of that group. The divisors are these, so therefore how many subgroups we'll have? 6. So this cyclic group Z18 has 6 number of subgroups. Okay, then we need to find what do we need to make the subgroups? We need a generator, right? So what is the generator? For a subgroup of order D, let's suppose the order is D, right? It is generated by a raised to n by d, which again comes from that theorem. So what does this mean? That for Z18, the element that generates a subgroup of order D is G, which is a generator, which is 18 by D, n divided by D. This is what we did from that theorem. It was n divided by D. Okay, so order of the group divided by order of the subgroup. This is the generator of the subgroup. Okay, so two things that we need to remember. We have to first find the divisors of n and then generator for the subgroup. Okay, now we will make subgroup. So the divisors are these, right? So therefore, what does this mean? That there are how many subgroups? 6 subgroups, right? Each subgroup is having order 1, 2, 3, 6, 9 and 18. So now we will make the subgroups. First of all, subgroup of the first order, which is 1. So 1 is what? 1 is D. This is the order of the first subgroup. Order is 1, therefore D is equal to 1. What is a generator? Generator is n by D. N is 18 and D is 1. So n by D, 18 by 1 is equal to 18. Now 18 does not exist in the group of Z18, right? So what is assigned to 18 is assigned to which element? 18 is assigned to 0. Therefore, what do we get? We get 0 as the first generator. Okay, now what are all the elements of Z18 that are generated by 0? Right, that is what we need to find, because we have to make the subgroup. So this subgroup has a generator 0. How many elements from Z18 are made from 0? Only 0. 0 plus 0 will give us 0, right? So there is only one element generated by 0. And we also know this is true because the order is 1. So there's only one element inside this subgroup. This is how you make the first subgroup. We apply the same method to the second one. So for second one is the order is 2. This is D, right? So order of the second subgroup is 2. Generator, again generator is 18 by 2, which is equal to 9. 9 is assigned to what? Itself, right? 9 exists in Z18, right? So 9 is the next generator. Okay, 9 generates the next subgroup. So how do we get the elements of the subgroup from 9? So that is going to be, first of all, 0, then 9 itself. 9 plus 9 gives us 18, right? 18 is 0 itself. 0 is inside the subgroup already. Therefore, the two elements inside this subgroup are 0 and 9. Again, the order is also 2. So you have only two elements, 0 and 9, inside this subgroup. Why am I adding? Because addition is the operation, right? Therefore, you get 9 plus 9, 18. 18 is assigned to 0. So there are two elements inside the subgroup, which is 0 and 9. Next, for 3, which is the next order. So subgroup of order 3, generator is what? Again, n by d, 18 by 3, which is equal to 6. Therefore, next generator is 6. Now, what are all the elements of Z18 that are generated by 6? 6 plus 6, 12. 12 plus 6 gives us 18, which is 0. So the next subgroup is 0, 6 and 12, generated by 6. So next, this subgroup is generated by 6, having 3 elements, because order is also 3. Similarly, perform for 6, 9 and 18. So for 6, the order is 6, which is D. Generator n by d, 18 by 6, which is equal to 3. Now we have to see what are all the elements from Z18 that are generated by 3, which will give us the next subgroup. So that is 0, 3 plus 3, 6, 6 plus 3, 9, 9 plus 3, 12, 12 plus 3, 15, 15 plus 3, 18, which is 0. So these are all the elements from Z18 generated by 3. Similarly, for 9, 18 by 9, which is equal to 2. So all the elements that are generated by 2, 2 plus 2, 4, so on till 18. So you get, these are the elements. Next, the last one, which is 18, right? So 18 by 18 is equal to 1. Now, what are all the elements inside Z18 generated by 1? It's the entire group Z18 itself, right? So these are all the subgroups of the cyclic group Z18. Okay, so this is how you do it. So basically what you need to do is you have to write the divisors of the group itself. When you get the divisors, now you know that these are the number of subgroups and all of these are unique. Okay, and the thing that you need to create those subgroups is a generator. It will create the subgroups for you, right? Like we got generator as 0, so 0 is creating this subgroup. We have the generator as 9, so 9 is creating this subgroup for you, right? So we need the generator which is n by d. Remember the formula, n by d. Okay, and that's how you perform this type of question. So these are all the subgroups: 0, 0, 9, 0, 6, 12, 0, 3 till 15, and so on. All right, that's how you perform these type of questions. So if you have any queries, you can write them in the comment box below. I hope this was clear, because this is a very simple kind of a question to perform for the exams. It's just a major concept that you need to remember, and then you're all set. So you just need to remember that you have to divide n and d. So n divided by d, once you do that, you'll be able to make the subgroups. So that's all for this video. Make sure you like, share, and subscribe to my channel, and then we'll be moving on to the next topic. That's it for today. See you in the next one. Bye bye.